Menjajar University melonjak ke hadapan. We are proud to be here and welcome all of you to the 11th International Conference and Exhibition on Sustainable Energy and Advanced Material, ISEAM 2025. On behalf of the organizing committee, I would like to take this opportunity to thank our distinguished keynote speakers and all the participants for making it today to kickstart our ISEAM 2025. Before we proceed with our agenda for this morning, allow me to brief all of you regarding the flow of the event. Right after this, we are going to have our keynote sessions where two distinguished keynote speakers will be delivering their esteemed talk. After that, we hope by 10 a.m. we will be able to end the session and get ready for the opening ceremony. We highly appreciate that you maintain your presence from the keynote session until we finish the opening ceremony at around 10:30 a.m. To mark this memorable occasion, a photography session will take place at the end of the opening ceremony. We hope that everyone can join the session. Tea breaks will be served at the foyer area before we all proceed to the parallel session at the designated rooms. Ladies and gentlemen, now we shall proceed to our next agenda with the keynote speech session. And for this session, we are pleased to have two esteemed chairpersons, Associate Professor Dr. Siti Haja binti Sheikh Mat Fazullah and Insinyur Dr. Siti Haja binti Khalid. Without further ado, we would like to call upon the first chairperson for the session, Yang Berusaha Associate Professor Dr. Siti Haja binti Sheikh Mat Fazullah. Please welcome Associate Professor Dr. Siti Haja.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, everyone. So, ladies and gentlemen, distinguished guests, it's my great pleasure to introduce our first keynote speaker of the day. We are honored to welcome Associate Professor Dr. Aditya Rio Prabowo, an Associate Professor at the Department of Mechanical Engineering, Faculty of Engineering, Universitas 11 Maret, Indonesia, where he also serves as the head of the Laboratory of Design and Computational Mechanics. Dr. Aditya's research expertise spans across marine and offshore structures, thin wall design, advanced materials, renewable energy supporting structures, transportation systems, and safety assessment, with an impressive record of high-impact publications and editorial contributions to leading international journals. He also serves on the editorial boards of journals under Nature, Elsevier, Springer, De Gruyter, Hindawi, and MDPI, and is the editorial-in-chief of Mechanica, Scientific Journal of Mechanics. His scholarly achievements include more than 26 H-index citations on Scopus, and his contributions extend globally as a reviewer, committee member, and advisor across multiple international conferences and scientific societies such as ASME, ISOPI, RINA, and ESIS. Today, he will be delivering a keynote speech on the topic Challenging Opportunity in the Northern Sea Route NSR, Future, Sailing Under Ice Rings and Hazard. Please join me in giving a warm welcome to Associate Professor Dr. Aditya Rio Prabowo. For your information, ladies and gentlemen, he will be joining us virtually today from UNS. Please welcome.
Ladies and gentlemen, thank you for coming to my presentation. It is a great honor for me to speak in this prestigious ICIM Malaysia Series 2025. My name is Aditya Reo Prabowo from Universitas 11 Maret, Indonesia. In this conversation, I would like to present a technical study entitled Challenging Opportunity in Northern Sea Road and our Future, Sailing Under Ice Risk and Hazard. The study will discuss the situation of the Arctic as a sailing path, including its advantages and disadvantages, and the structural characteristics after experiencing interaction with ice as expected. A brief literature review is presented together with several structural responses as calculation results. Let's begin the session. As introductory to my academic info, currently I serve as an associate professor in a state university, specifically in the Department of Mechanical Engineering, Faculty of Engineering. I graduated from Kyoto National University in Busan, South Korea, approximately 7 years ago, and now I focus on several research projects and grants related to thin wall design and structure, marine and water pollution, accident and safety assessment, which lead to this presentation. This presentation itself is divided into 5 main chapters. First is the introduction to NSR state and potential. Second is the fundamentals and material property. Third is engineering of ice collision. And fourth is the structural risk and after impact. The final part is the conclusion and future works. First chapter, introduction. In this section, we will examine the background and significance of the study. As a global warming result, ice in the Arctic Ocean is melting and decreasing. Statistical data in this slide supports this phenomenon. The map of the Arctic Ocean in this slide represents the ice condition during winters, and it's also evident that the route through this ocean is blocked by ice. In the opposite condition, where the temperature is getting warmer, such as in summer, the ice is melting and the path is open for international shipping routes. Despite these two conditions accounting for temperature, the effect of global warming, as said before, can be taken into consideration that in the future, the Arctic Ocean may remain open during winter due to the decrease in ice, and it can be used throughout the year. Ice states in the Arctic and Northern Sea roads have become extraordinarily dangerous on a global scale for many reasons due to the melting condition. Data suggests that the extent of Arctic sea ice is shrinking by 13% each decade as the world warms. For example, a portion of the West Antarctic ice sheet background drains into the ice-covered Bering Sea, which wipes out the ecosystem in the polar regions. Furthermore, ice flows in Baffin Bay above the Arctic Circle can threaten the structural integrity of sail ships that carry hazardous cargo. The latter condition is not mentioned without any actual evidence. As shown in the top left picture, it is the Arctic regions and the shipping path through the large marine ecosystem of the Northern Sea Road. Based on calculation by the Norwegian Institute for Water Research, the number of ships through the NSR has been rising year by year since 2013. These ships include fishing vessels, general cargo ships, cruise ships, and passenger ships. It's also found that crude oil tanker, gas tanker, and offshore supply ships from the offshore drilling sites are using this route. Specifically, the busiest port is Karakiv in Russia, which consists of Yugorsky Strait and Franz Josef Land, Novaya Zemlya, and Long Strait and Wrangel Island in the North Pole. In this slide, we will assess the charm and allure of the Northern Sea Road, especially for the global export-import market in Asia and Europe. This illustration represents the comparison between two main shipping routes. SSR stands for the Southern Sea Route and NSR for the Northern Sea Route. A study on distance, time, and consumption for shipping from Asia to Europe was conducted, and as shown here, the Northern Sea Route has more advantages than the Southern Sea Route. The distance through the NSR is reduced by 3,897 nautical miles. Sailing time is reduced to 11 until 18 days, and the fuel consumption is reduced approximately 25% to more than 1,000 tons. More researches for other destination points were also already conducted, and as we can see, most of the shipping routes achieve advantages by using the Northeast Passage. Despite the discussed advantages, this route poses risk and hazard to sailing ships, particularly due to the Arctic's ice environment. For instance, a major disaster was averted in the icy Kara Sea after two oil barges ran aground, resulting in an oil spill in the polar ice environment. In worse weather and stormy conditions, a research ship and passenger cruise may trapped in frozen seas. Based on all the mentioned accidental cases in NSR, the particular problem and risk in using this passage is the expectation of collision with ice. In several severe accidents, the damage to the ship hull is found to be massive, resulting in additional costs for repair, which will, of course, result in a loss for the owner and the industry. If the weather is bad, seawater can enter through the damaged part and decrease the ship's stability or even sink the ship. Considering these devastating chain reactions, the present study aims to investigate the structural characteristic that occurs after the ship collides with ice. The next chapter is fundamentals and properties. The method and procedure from previous work will be introduced as the next stepping stone in this study. And also, we will discuss about the energy theory based on the properties of ice and steel ice materials. Basically, there are four known methods for assessing impact phenomena, including ice. First is the empirical formula method. Research such as Minkowski and Weiser introduced and defined the formula, dividing it into two parts, high energy conditions and low energy conditions. On the other hand, they concentrated on the impact of the steel structure on the ice. The second, or the right side of this slide, is the analytical method. This method employs the upper bound term and is typically conducted in conjunction with the model experiment. The next one, the third, is the numerical simulation method. With the rapid development of computational equipment, numerical experiment is used in research for almost all branches of science and technology, such as using computational fluid dynamics and also finite element methods. Previous researchers such as Kamura, Bay, Harris, and Amdahl stated and indicated the numerical experiments were judged powerful enough to analyze engineering problems, especially impact phenomena. The fourth method is the experimental. This method was conducted several times in the Netherlands, Germany, Italy, and Japan, which involved a full-scale experiment. Experiment on the contact between steel and ice have been conducted in recent years in several countries, such as South Korea, China, Norway, and also Denmark. This slide presents the analysis scheme for ice load in the collision process between the structure and ice. The ice load is divided into three parts. The first is the ice condition, the second is the statistic of the ice load, and the third is the mechanism of the ice load. The data for these definitions can be obtained from literature reviews, statistics, and experimental studies. The defined ice characteristic is deployed in a further study of the impact, which can include collision and grounding. The flow chart in this slide represents the mentioned study, the interaction between the steel structure, in this case a ship, and ice. As is known, basically the collision phenomenon involves numerous parameters which make it produce high nonlinearities. For example, in this chart, several parameters are presented, including the colliding body of ice, load mode on the ship hull, which is divided to static and dynamic, and material properties. The study that used characteristic under the red line, or in this case is orange, as can be used in the presentation is known as fluid structure analysis, or FSI. Professor Delay introduced a formula that can be used to establish the ice load model, which can also be used for interaction simulation between structure and ice. The formula of available kinetic energy, or KE, is equal to the sum of energy expended in the crushing and potential energy. Furthermore, indentation energy is the integral of indentation force on the crushing indentation displacement, while potential energy is obtained from recoverable displacement. These three basic formulas are fundamentals of solving for structural ice interaction. These equations provide information indicating that kinematic and geometric values must be known to create an ice model. The preceding three formulas are the basis of solving for the ship-ice collision. The first equation can be solved for Fn, provided that the required kinematic and geometric values are known. It can be seen that the maximum ice load in every case and the ice load range can be calculated using the ice load model. The ice itself has different physical characteristics and is divided into two general ice zones, namely the fast ice zone and the packed ice zone. An example of a packed ice zone is represented by the rich field in the northern Baltic, which is also included in the transition ice zone. As for the fast ice zone, it features more open sea ice cover with ice-rich level ice area and open water patches similar to those found in the Gulf of Finland. In the preparation step, Robert Gagnon developed an ice model based on the crucible foam material, where the deformation is primarily unrecoverable. The assumptions also covers a characteristic that a small Poisson ratio limits the deformation in direction other than the applied loading direction. Besides studying ice models, studies on the steel material in Arctic collision were also performed by various researchers. An example here is the material properties of steel at different temperatures from the research consortium of Hyundai Mipo Dockyard, Mokpo National University, and the University of Ulsan, South Korea. According to the study, which involved three temperatures such as room temperature minus 30 degrees Celsius and minus 50 degrees Celsius, it can be concluded that the properties of steel in Arctic condition proved to be stronger than those at room temperature. The implementation of specific material for ship hull as presented in this research can help reduce losses in the event of an accident. Chapter 3, Engineering of Ice Collision. This section will discuss the collision interaction scenario and finite element model used in the numerical simulation, as well as an illustration of the target area during the impact process. In the collision process, several possible collisions can be taken into consideration. First is a glancing impact, where the side structure of the ship slides and experiences friction with ice. Second is compressive or pressure ice. This situation occurs when a ship passes through a narrow tunnel, causing ice to exert pressure on the ship as it moves forward. Third is shoulder glancing impact. After the collision, the ship moves in the swaying direction and comes into contact with other ice. Fourth is the impact of turning a As its name suggests, the collision happens when a ship tries to change direction. These are the principal dimension and midship section of the target ship for the present study. Ship is a 144-meter double-hull chemical tanker and can be seen in the illustration. The substructure of the ship is dominated by longitudinal structure. The structure of the chemical tanker will be designed in actual size to provide the real-size construction damage under icing. To obtain satisfactory result in terms of deformation pattern in a reasonable time simulation, several sizes of mesh are applied to the side structure, which has been visualized in this slide in form of 1-to-1 size finite element model of the tanker. The smallest is used in the core region where contact with ice is expected during the process. In the edge region where contact with the injector or ice is unlikely to occur, the larger mesh size is used among all areas. These are three target areas on the side structure of the structure, which are denoted as area A, B, and C. A is the structure that is strengthened by a transverse frame and a longitudinal stringer. B is a stringer between two frames, while C is on the outer shell between two frames. Each location is selected to assess the formation on a specific structural member as presented in this slide. In the interaction between structure and ice shear, three ice shapes are used as indenters, namely triangular, hemisphere, and comprehensive. These geometries are designed with constraint on maximum height 600 mm, width 6,000 mm, and radius 3,000 mm or length to localize the shape effect on the induced damage. Chapter 4, Structural risks after impact. In this section, the result of the given ice collision parameters are presented and discussed, including the mixture, pattern, energy ratios, and impact forces. To summarize the condition during collision impact or ice structure interaction, the compressive impact was taken into consideration as if the ship were moving through a narrow channel. The structure of the stroke ship was modeled after the middle region of chemical tanker and used as study area. This slide presents the damage pattern at the moment ice contacted the side structure. As expected, the damage was found to be more extensive than the other two ice. Non-linearity of ice itself became the main factor, which means this ice type would deliver damage to two transport frames at the same time. The same case was also found in the hemisphere, but the sphere shape tends to be more linear than the previous one, which makes the non-linearity in damage caused by this ice type less comprehensive. Despite the destroyed material on the outer shell, which can be seen on this side, the inner shell can withstand the impact load of three types of ice. In this slide, the impact force of the substructure accounting for ice shape is presented. The shape of ice was contributed to produce a different damage pattern. However, in the force characteristic, similarity was observed in the collision process across the two time periods. The first highest point, which was denoted by A, occurs when the outer shell begins to fail and plastic deformation on this part starts taking place. As we can see, the force then decreased for a short time after this moment. The second point, which was denoted by P, indicated that several inner members start failing. At the end of the collision time, the energy still increased because if the simulation will continue, further tearing of the structure was expected to occur. Total energy and energy ratio of each structural member are presented in this part. Structural member on the outer shell, such as shell, frame, and stringer, is expected to experience high energy, which also indicated that more energy is required to destroy this part than the inner structure, as the inner structure or inner shell was not reached during the collision process. The total and ratio of energy for this structural member tend to be flat in the range of the collision period. The comparison of the braking times of 3 target points is presented. Impact area A was concluded to be the longest one among the 3 targets. This result matched the structural characteristic of each target point. The structure that has more members strength will need more time to be destroyed. The results also indicated that the location on the shell between the 2 frames was the most vulnerable. Besides ice shape and the location of the target points, the definition of ice characteristic was also compared in this study. During the time period between 0 and 0.2, it was observed that the result characteristic of crucible and rigid material were similar, despite differences in impact force, acceleration, and displacement of the inner shell. The impact with rigid body characteristic could be concluded as more massive than crucible ice, which could be used to estimate raw worst damage during ice structure interaction. Chapter 5, Conclusion and Future. In the final part of this presentation, I would like to make several concluding remarks and recommendation. 1. Northern searoads are appealing to involve parties in the global trading market and shipping industry, as the cost for shipment can be reduced due to shorter trade distance from Asia to Europe. 2. Nevertheless, risk and hazard due to interaction between the ship as a transporter and ice in the Arctic regions are undeniable and require serious attention to avoid large-scale disaster such as oil spill, life loss, structural damage to the ship, and more. 3. The present analysis on data produced by the finite element approach confirmed that the damage condition after the structure contacted ice in a comprehensive situation may be little. 4. Until 5, we can discuss about the damage and also the casualties. It is water can enter the ship hull in a post-impact event, which directly affect the stability and may destroy the ship cargo. As for the recommendations, statistical condition can be applied in the subsequent study to compare its result with the present study. The experimental method is highly encouraged to be conducted by the present author if the resource supports the foundation for performing ice structure analysis. This concludes the presentation. I want to thank all contributing researchers and professors to this part of the ice structure project. Please do not hesitate to provide me a comment or recommendation during the next session. Thank you very much for your time and attention.
Thank you very much for the presentation by the keynote speaker 1. So now we open the session for Q&A. We will take a maximum of 2 questions because of the time constraint. So if anyone would like to raise a question, please come forward to the mic here, because we are having a hybrid session right now. Any first question from the floor?
Assalamualaikum, Prof. Aditya. Thank you very much for the presentation, a very interesting one. Can you share what are the challenges that you have encountered since the modeling that you have made to me personally is very extensive and very detailed. So in terms of the computational requirements to perform such delicate analysis, if us would like to try to explore on the same application. Thank you.
Okay. I will try to answer. I hope that my voice can reach the venue. Good morning, all. Thank you for the questions. Yeah, I understand that the ice structure interaction, or in this case, is interaction between ship and the ice in northern pool simulation will be complicated, especially if you consider the actual size, such as presented in my presentation. You have to model actual size of tanker about 100 meters more. It will requires more computational time, and also it will requires time to remodel the ship. In this case, we have several ways to make the simulation or make the analysis more comprehensive, such as in these days we developed test models. For example, I know that Malaysia also has signed the pact to expedition for Antarctica or South Pole, and then maybe this will be a good business opportunity in Malaysia in the next few years. And they, you can develop an ice model, so you have to do the experimental ice benchmarking. You have to remodel the ice as the actual geometry, and then you conduct the comprehensive test, such as you conduct using universal testing machine. And the second part, you have to, we can very detailed simulation based on the simplified model of the ice. But in this case, we have to remodel the ice material, such as, in this case, I use foam, crucible foam from the ice dyna, and also etc. But you can also use the other simulation software, or you can also develop your own algorithm or syntax using Python, etc. And then the third stage to conduct this simulation, if this the complicated case are involved in the coding condition, we conduct the remodeling of the shape of the ship, such as in this case we don't have to use all the shape as the model, but instead we use the panel or stiffened panels from the side structure. As I mentioned in my presentation, the contact point was placed on the side structure, so we have to remodel the stiffened panel, just stiffened panel. And then in this case, we can have the more simple model, and then we have to involve all models. But this model is actually good for the study and then also parametric research. Nevertheless, as far as I know, for the industrial scale, we usually require to remodel the ship or any other, for example, the offshore rig in actual scale and also in actual model, because they require the detailed information regarding the stress behavior during the contact. I hope this is my question can answer your question. Thank you very much.
Thank you very much for the long explanation and a detailed one. Perhaps, is there any question among the participants? Postgraduate students, any question? Or our international students from Japan and Indonesia, do you have anything you're curious about? Okay, with that, we are very grateful and delighted to have you to join us today virtually, and we look forward to collaborate with you more. Thank you very much, Pramaditya.
Thank you very much.
Thank you, everyone. We'll pass it back the session to the chairperson. Thank you.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. Very good morning, everybody. How are you? So we hear so much noise from the next room. Do we want to make noise? No, we don't. I just want to break the ice because we start really cold, right? Okay. So, ladies and gentlemen, it is an honor to you to introduce you our second keynote speaker, especially from University Technical Malaysia, Melaka. We are pleased to welcome Associate Professor T.S. Dr. T. Boon Tuan from UTEM. Dr. T is an accomplished academic researcher with over 2 decades of experience, specializing in energy management, computational fluid dynamics, and green technology. He earned his PhD in engineering from the University of Cambridge and has since held multiple leadership roles at both the university and national levels, contributing significantly to research, administration, and sustainability initiatives. As a certified energy manager and green building facilitator, Dr. T has secured numerous research grants, published widely in high-impact journals, and actively collaborated with institutions locally and internationally. His work is dedicated to optimizing energy efficiency, improving building performance, and advancing sustainable solutions for a greener future. Today, he will share his insights in a keynote speech titled Smart Energy, Smarter Buildings, How Data, Sensors, and AI are revolutionizing sustainability. Please join a warm welcome to Associate Professor T.S. Dr. T. Boon Tuan.
Okay, thank you very much, my friend. Okay, thank you very much to my friend, Engineer Dr. Siti Noida, for very kind introduction of myself. Okay, I'm very humble with that. And thank you to the organizing committee for appointing me to become the second keynote speaker for these sessions. Right. So first of all, I would like to salute Yang Berusaha Associate Professor Dr. Nadlin Razali, which is the Dean of Faculty of Mechanical Technology and Engineering, okay, UTEM. And Yang Berusaha Associate Professor Dr. Muhammad Rizwan Mansoor, Chairman of ISIN 2025. Yang Berusaha Professor is Engineer Dr. Ubaidillah, the Honorable Representative from Universitas 11 Maret, UNS. Yang Berusaha Dr. Jack Fabian Rusti, the Honorable Representative from Universitas Teknologi Bandung, UTB. Honorable guests, my fellow organizing committee members, ISIM 2025 participants, ladies and gentlemen. Okay, so good morning to all of you. Okay, so as you see, the topic for today's keynote is actually about smart energy and smarter buildings. Maybe you sound more futuristic, but what I'm going to share with you today is basically more on the real world applications of some of the data and also the progress. Okay, basically, nowadays building is not longer about bricks or mortar. Okay, basically it's based how you're going to reset those control inside the building. For example, it's saying what you think is the building can talk to you. That's the thing. Not saying I try to focus on those spiritual things, not really. It's actually in terms of what if they knew when to turn down the aircon before the sunset. I mean, when it can regulate the temperature by itself, okay? And then you can dim the lights based on the mood and so-called works as a nervous system. Alright, so in this case, I'm going to share more on this how the smarter building helps in terms of the technology-wise, that involving the data, the sensors, okay, and of course now with the trend of artificial intelligence, in terms of contributing towards sustainability. Right. So was not working. Okay. Okay, let's go to the first part. This is actually on the terms of the global energy. Alright, basically we know that building consumes basically about 30 to 40% of global energy. This is something that has been proven in the most of the literature. And as for country like Malaysia, hot humid, air conditioning is part of the main contributor because we use aircon a lot, okay, in order to regulate the temperature inside the room. And in case of now, how is it we're going to manage in terms of the energy usage? Because it's related to the sustainability in the world. And what now is changing is basically the technology which is enable us to do more prediction in terms of the surrounding. Okay? Rather than because it's only just we use technology to control, but now how we can use this technology to enable for the predictive conditions. And then in this case, building, we learn about how the situation of the surrounding in order to control and respond. Okay? So this means in a way building are no longer statics. They are system that they think. In a way we try to regulate the system and then the building can respond to it without a lot of human intervention. That's the thing. Right? So when we talk about the... Okay, now we move to the energy and sustainability dilemma. Okay, this is something that we try to work out on that because for a long time, normally we rely on the fixed schedule in terms of how to control the building. For example, we turn on light or aircon during office hours between 8 a.m. and then we turn it off at around 5 p.m. Okay, regardless whether anyone inside the room or not. Okay, we operating in that way. So this rigid approach basically leads to three big problems. The first one will be the overcooling. This means it doesn't deliver with the condition that we need. Okay, because sometimes you don't have people inside the room, but then the aircon is still turning on. And then in that case, it causes a wasted electricity, right? And this includes in terms of lights, aircon and ventilation, even when they are not needed. And then the next one is the discomfort, okay? Because the temperature setting that we expect it to deliver a comfort situation is not happening, right? So sometimes people often feel too cold in the morning and then too hot in the afternoon, right? And also complain about the poor air quality due to the misaligned controls, right? So this environment doesn't follow a schedule and people sometimes don't either, right? That's how we move from meeting rooms to breakout and we move, we keep mobile ourselves, and also the weather patterns will change the situation by the hour. So the challenge is now is whether how do we balance this comfort and sustainability together, not with just guessing whether it can deliver, but with the intelligence. I mean, you use the intelligence of technology in order to regulate the condition. So we need to shift the condition from rigid or timer-based that we used to do to more to the adaptive, responsive environment, which is where we involve those technology of artificial intelligence, IoT, and data-driven automation coming. And beside that, we also using the input. For example, like the real-time occupancy data, and then weather and solar radiation, and also indoor air quality metrics. And this, we try to think like we drive a car, right? Would you like to leave the engine on even though you're not driving? So that same goes apply for the building as well. If we are not in the building, then we expect the building regulate and turn off everything at one go, right? Without the human intervention. Okay. So let me bring you to one of the case study that I did before. This one in our own university building, where basically we collect quite a long data, me and my students, okay, from 2010-2018 that time, where we try to see the correlation between the actual campus electricity usage in terms of the air conditioning, right? So you can scan the QR code in order for you to access the paper, so it's easier for you to refer. Okay, so in this case, we use a statistical method, which is called as the Finkelstein-Schaeffer FS test, where this test to identify how closely each year matches the long-term average across all weather variables, including the temperature, humidity, rainfall, solar radiation, because this is what's happening in the hot, humid country. And then the goal is actually to generate the which is a test reference years, which is like a climate fingerprint on the location. So what the outcome is actually a clear pattern where we notice that as the temperature rose, energy demand for cooling spike. There's always the logic, right? When you have a hot temperature outside, you tend to lower down your aircon temperature inside the room. Okay, so during rainy season, humidity level surge, and this actually triggering more latent cooling loads, which is particularly in the lecture halls and labs with poor ventilation control. And besides this study also, we saw evidence of delayed thermal effects, which is hot afternoon led to elevated energy use into the evening hours as heat build up in the building envelope. Okay, and this tells us actually something important. Real-time energy monitoring is not enough. Okay, even though you set the time and setting, we need a very predictive planning that accounts for seasonal and climatic trends. Okay, this is the data that I will collect, which is compiled inside here. So you can see that there's a red line which is representing the monthly average temperature. Maybe because due to the scale, you can see that it looks like a bit static, but actually because there's a difference in terms of the temperature rise between each month. And then you see the monthly rainfall together with the green bars, which is the electricity consumption in terms of HVAC related. So in this case, you can see that from March to May, temperature peaks and energy consumption rises sharply. And in September to November, where the rainfall increases, and interestingly, so does energy usage as well. Okay, so this means the insight here are very powerful. Rather than you reacting daily, the burning system can be seasonally tuned. For example, we can use a pre-adjust thermostat settings, or we could also optimize dehumidifiers and also ventilation system. And this transform the energy management from reactive in terms of firefighting, in terms of that, into proactive climate intelligence. So this data actually help us in terms of how we can do a predictive energy budgeting. Okay, so now we go to the next one. This is another study that I did in the smart office, basically. So why smart? Because almost every single part of the component inside that building are installed with sensors. Okay, this is located in Selangor. This is under the one company, and they use a KNX types of system, smart office. So in this case, the smart sensor they detect in terms of the lighting, lighting, and then the motion detectors, right, and then CO2 as well, and also daylight responsive blinds as well, and also together with the HVAC control. So in this case, the light dim automatically. This means by regulate in terms of the sense of people inside the room, it can regulate automatically without any human intervention. In terms, you don't use any remote or whatever. And then the HVAC scale down when rooms were unoccupied. And the next one, the blind adjusted automatically when you have a very strong sunlight coming up from outside. Okay, so this is what's interesting about this building. So the impact of this smart office basically there's a 30% of energy reduction. When my team do the reading, we do the data collection, 30% reduction in overall energy consumption. This means those technology of regulating by itself automatically actually help in terms of the energy consumption. And then there was no complaints in terms of discomfort by the staff or the people inside working there, and also a better indoor air quality and also thermal comfort. Okay, so this is part of the study that we look at in terms of smart office. Okay, so from there, what the sensor tells us, basically, in the way sensors collect the data of the movement, okay, temperature, CO2 level, humidity, and also ambient light. So the real value actually lies how this data become a conversation between space and system. I mean, this data when we collect, it can do the prediction automatically. Alright, so in this case, we move when the building responds. For example, when the sun rises, the light dim. Okay, we no longer need the sun. You don't need the light actually, and you use a fully on sunlight. And then when the CO2 level spike, okay, fresh air flow in. Because imagine if you have a very high CO2 level inside the room, you can tend to have more suffocation. You're very hard to breathe and so on. This is also another issue to look at. Okay, so from the data to action, basically in traditional building, you need a human to act. That's common, right? We use a remote and then we control everything. Okay, so someone has to notice the light is on, or feel the static air, okay, in order to adjust the environment. But in smart building, the feedback loop is closed. So this means the building senses, okay, decide and also reacts in real time. So this means so-called like the building has a life there, okay, they sense the environment of the surroundings. Okay, the next study I'm going to share with you is one of the so-called like the AI framework using the this called multiple linear regression and also piecewise linear regression. So in this case, we conduct in the same another university building. So we look at on the real-time indoor air quality sensors. This include the CO2 concentration, okay, humidity levels, and also indoor temperature. Right. So the result is quite amazing in the finding basically, where the prediction that we found actually accurate, about 95%, and the system could detect when the room was likely to become crowded or based on rising CO2, and also it preemptively activated cooling or ventilation. So most traditional system actually wait until a set point is crossed, right? When you set the limit, then it react on that. But then for this one, when you do that, its comfort is already compromised. For example, we know that 24 degrees Celsius for aircon setting can consider is a comfort level, but sometimes it's not happening. It's not happening, and sometimes it's different in terms of the thermal sensation for every people. And then the HVAC system has to work harder to catch up, and energy is wasted in the process. Okay, so these are the graph that we found for this one. So in this case, from the model that we made, actually it learned the pattern of human behavior in terms of how is it when people start to work, okay, and typical room usage and indoor climate response. And also it anticipated in terms of spike in thermals and also CO2 and activated cooling and ventilation before the threshold were crossed. So the impact on this is very interesting for comfort and efficiency, where you think about your own office, your office room, okay? How often when we walk to our room or meeting room, we feel either very cold or stuffy and stale. This is common for us, for our building in the technology campus. And then when you have the so-called artificial intelligence to come inside here, it can regulate and you can reduce this type of situation. Okay? And then the system also optimizes energy without sacrificing comfort. So this is something that is interesting to look at, which is to reduce the complaints and then to produce a more healthy indoor air and also smoother HVAC performance. Alright, so we also did some bibliometric study actually to look at on the global research trend. And then in this case, we tried to review some of the high impact papers, about 407, we'll go on through all that. Okay, and we look at some of the common that happened in China, in the United States, and also key parts of Europe, and also together in Southeast Asia. So there are top 3 focus areas that we found out. And the first one, we look at the interest on the energy optimization, which is how to minimize energy use while maintaining performance. And then second is smart HVAC control, which is integrating real-time decision making, okay, into the air system, and thermal comfort modeling, which is ensuring occupants aren't too hot or too cold but just right. Okay, so the important part of us here is actually in our country, in Malaysia, and of course in the Southeast Asia region, where in this case there are quite a few studies actually that has to be done for those tropical climate, where our buildings experience in terms of persistent humidity, high solar gain, unpredictable weather bursts. Currently now we can see sometimes we have very high temperature in the country. Okay, and this is part of the blind spot that we can explore more in future research. So while the world is talking about AI in the building, so the question is are we leading the conversation? Or are we merely importing solutions designed for different climates? Okay, how we can regulate based on different climates of every region, and then different user behavior and different infrastructure. This you can see the spectrum is quite wide. Okay, but then it's not impossible to be catered. Just a thing. And then it's time to build a climate responsive, cultural, adaptive, and also regionally inclusive solution. This is the current trend of research that people are looking at. How they can have one particular framework that can apply to most of different regions or can regulate by itself automatically. Okay, so the next one we say what are we moving towards us? Okay, what are we looking at in the future? Okay, the next one we are looking on the HAI, which is instead of sending all sensors data to a central server. Edge computing bring AI directly to the device or local controller. This is part of the application that we can implement. The next one is the self-learning HVAC system. Okay, this is where imagine that your aircon system that observes your behavior. Mean it can regulate based on how the occupant behave inside the room. It's crowded, suddenly automatically it can reset the temperature, and then you feel comfort about that. And then no more static set points. This is what our current trend we did, right? We put a set point and then the system will react based on that particular set point. And then you see this technology not just theoretical, basically they are already being piloted in some of the smart campuses, in the green certified hospitals and also university classroom. Okay, the other part will be integration with the renewable energy. Okay, this as we in the hot humid country, then we try to embed the solar energy in order to not rely so much on the current electricity. Okay, and then a real-time feedback via IoT. This is another good technology in terms of trying to get the response or the data and also the survey that directly to the system. And finally, it's a digital twins, which is virtual replicas of real building. This means before you build that building, you already have the idea how it's going to be the operate or the operational condition inside it. So they fed with the real-time sensor data and can simulate how a building will behave under different conditions. Okay, let's move to the case study 4. This is the last one that I did for the digital twin in building. So in this case, this is actually an earlier framework. You scan you refer to the paper, so in 2018. At that time, we tried to create a live simulation of the building's indoor environment using a real sensor data. At that time, we tried to regulate in terms of temperature, humidity, lighting, and also CO2, and using the current tools that we have at that time, which is IES. And then with the programming code of Python and also Agon, the team actually managed to monitor and simulate building energy trends in real time. So this actually is a great example of what possible even without full-scale commercial solution, just smart integration of what already available. We utilize that, and then we can see how it can use as a framework to predict a building which is not yet built, but then you can know how is it behave or how is it the condition inside the building. Again, we call it digital twin. Alright, the next last part basically look at on the practical step for today. So we know that the main issue about implementing all this high technology, high-end artificial intelligence is the cost. Okay, so basically the good news is we not really say we need to spend quite huge sum of money actually in order to implement those technology that we have. Okay, we actually can start with the smart sensor retrofit. Okay, because most of the motion sensor, temperature probes, CO2 monitor are now affordable and also scalable and also often wireless. And then step 2, it should build a climate energy profile using the reference here earlier. So we can look at on the historical electrical bills and then combine with the weather data. Actually, we can generate this test reference here in order to reflect how the campus or the office typical condition. Okay, so just use the what we have, right? And then the next one is to look and integrate simple AI tools, like we use the P-SWAT models that can help predict energy usage and also occupancy, humidity, and also CO2. Right? And the last part will be actually focused on the low-cost, high-impact automation points. Right? So we to ensure the rooms are always comfortable and always the air is always fresh, and also system respond without waiting for complaints. Okay. So the key takeaways for my keynote today, basically we see that we started with the challenge earlier, where we say that the building consumes up to 40% of our total energy, which is a significant contributor to climate change and also operational costs, right? So, but we also saw how much that is unnecessary waste, and then especially from outdated practices like fixed scheduling, manual control, or ignoring climate patterns. So then we see some of the opportunity by using the weather-driven analysis, real-time sensing, and then AI-powered HVAC prediction tools, and also smart automation that delivers efficiency and comfort. Okay, and we see some of the case study that involving the UC campus, smart office, and also some of the university building that I have shared the case study earlier. Right? All right. So the key message you can leave behind here, basically the smartest building is not the one with the fanciest glass of steel, okay, the architecture and so on. It's actually the one that learns, that adapts and that evolves. Okay, this means it responds automatically, and this kind of infrastructure we should be building actually, most in our region, where climate resilient, cost sensitive and user centered design isn't optional but is essential. So for the final thoughts, I would like to quote from Winston Churchill. Well, of course, when he put this kind of quote, he said, "We shape our buildings, thereafter they shape us," which during that particular time, in the 50s. But actually, it's relevant with current, because when we're talking about smart building, we actually would like the building to actually help in giving all the information and also treat the occupants and understand to respond what the occupant needs. Alright? So in a world shaped by climate urgency, like what happen now with the global warming and so on, and so data abundance and also digital disruption, how we design, operate and interact with buildings is becoming a powerful reflection of our values or priorities as a society. So the question is, what kind of future are we shaping through our buildings? That's the thing to look at. And it's no longer enough just to install a green certified lighting or submit a checklist for compliance. Because when you go for certification, they will check there's some criteria of compliance that you need to follow. And green certification actually is good for a case, but it's not just a starting point. Okay? What we need is actually the green intelligence in the way we try to acknowledge the technology, which is also contribute towards the sustainability, which is heading towards the green environment. So with the right data, sensors and AI, okay, our buildings can now learn from us, adapt for us, and even act ahead of us. Okay, making every single watt that generated count and every space smarter. And this isn't just a technological shift; it's a sustainability revolution. Together, let's build a future where our structure are not just green, but genuinely intelligent, human-centered, and climate-conscious. Okay, because when we align smart energy with smarter thinking, sustainability is not just possible, it's become inevitable. So with that, I conclude my keynote presentation. Thank you very much.
Thank you, Dr. T. Guntuan, for the inspirational presentation. And now I open the floor for question and answer. We can only have 2 questions because of the time limit that we have. May I have question or 2? All right, please.
Hello, good morning. My name is Adib. I'm from Masjid University. I'm a student of Foreign Discovery Camp. I'm actually a master student in industrial engineering. And in Indonesia, I'm actively building a renewable energy system. And right now, I'm doing a research on renewable energy system efficiency and predictive improvement analysis using AI, similar to your third case study. And for now, I'm still on the process on doing it, and I wanted to ask, and maybe just wanted you to share on what is your difficulty and your obstacle on doing your particular research. And yeah, for me right now, I'm having difficulty on the data collection and monitoring system because it sometimes doesn't give us the most precision data. And I think for AI training and energy monitoring, precision data is not needed. And for you also use linear regression. And do you have suggestion on what type of algorithm should we use or any suggestion on method? And the main thing is, what is your method on collecting the energy data for your research? Thank you.
Right. So I guess 2 questions, right? Okay. First, I answer the first one, which is challenge. Like I mentioned to you earlier, in terms of spectrum, it's quite broad in a way because we want to make sure that we get the accurate data. That's the thing, right? So when we try to measure conditions like inside this room, for example, so we can see that in terms of occupants, it's sometimes very hard to control, especially like office building. People come and go. Okay, they come and go, and that's one of the challenge, right? how you're going to make sure that the data that you collect is actually represent the total amount of occupant inside the room. And then second, the weather, like what I highlighted earlier. The weather, in terms of the whether it's sunny or it's raining, is actually impact in terms of how we control the temperature inside the room. Alright? And then another one is also some of the minor things like the situation, the design of the building, where the leakage coming in. This also actually impact in terms of the fresh air or CO2 and so on. This part of the challenge that I said we need to do a lot of kind of few variability in terms of how we're going to regulate. But then this is something that current researchers are looking at. How we can, if we can want to set one framework of measurement or data or the system, it can implement for most of the condition and also apply on different regions. Okay, in terms of the linear regression earlier, okay, like what my team did earlier with the piecewise regression, that one is actually seems can give a very promising result. But I don't say very 100%. Like I mentioned to you, when we do the correlations, about 95%. Okay, still have 5% flaws from that. Okay, so basically that's part of the common idea that you can do. And then with the current lots of AI technology coming in using machine learning and so on, I think you also can try to use part of that tools in order to integrate or try to cross-check in terms of your data measurement. Okay.
Right. Can I have another question, if there is any? Okay then. Thank you everyone for the session. And close today's session with Wabillahi Taufiq wal Hidayah. Wassalamualaikum warahmatullahi wabarakatuh. And a round of applause to everybody who joined.
Ladies and gentlemen, thank you so much to our two beautiful cities, Associate Professor Dr. Siti Haja binti Said Mat Fazullah, and also Insinyur Dr. Siti Nurhaida binti Khalid. We will be starting our next session, the opening ceremony, shortly. While we await for the arrival of our Deputy Vice Chancellor of Research and Innovation, we kindly invite everyone to remain seated, relax, and perhaps take this opportunity to get to know each other and enjoy a light conversation. We will start the next session at 10:15 a.m. Announcing the arrival of the Deputy Vice Chancellor of University Technical Malaysia Melaka, Yang dihormati Professor Dr. Zamril Adha bin Zakaria, accompanied by the entourage into the hall. You may now be seated. To begin our ceremony, I would like to call upon Dr. Shafiza bin Mat to lead the Dua recitation. Please welcome.
Assalamualaikum warahmatullahi wabarakatuh, and very good morning to everyone. Al-Fatiha. Bismillahirrahmanirrahim. Alhamdulillahi rabbil alamin. Wassalatu wassalamu ala ashrafil anbiya wal mursalin wa ala alihi wa sahbihi ajma'in. Ya Allah, Ya Rahman, Ya Rahim. Praise be to God, the Lord of the world. Peace and blessings are upon our Prophet Muhammad sallallahu alaihi wasallam and his companions, and for those who follow his example till the judgment day. Allahumma ya Allah, on the blessed morning, in the conjunction with the opening ceremony of ISIMS 2025, we are grateful towards you in favor of all the infinite blessings to us, your humble servant, to live a safe and prosperous life. We seek your blessings for the flawless progress of this event from the beginning till the end. We seek your guidance to steer clear of the event and that will be detrimental to the progress of this event. Ya Allah, kindly give us strength and courage to face the struggle, to find and gain knowledge. Kindly bestow blessings, physical and spiritual health, fitness of mind, peace of mind, strength of spirit. Ya Allah, grant strength to our teachers and leaders to continue to serve for people, society, nation, and religions. ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب. ربنا لا تزغ قلوبنا بعد إذ هديتنا وهب لنا من لدنك رحمة إنك أنت الوهاب. ربنا آتنا من لدنك رحمة وهيئ لنا من أمرنا رشدا. ربنا آتنا في الدنيا حسنة وفي الآخرة حسنة وقنا عذاب النار. وصلى الله على سيدنا محمد وعلى آله وصحبه وسلم والحمد لله رب العالمين. آمين يا رب العالمين.
Thank you, Dr. Shafiza bin Mat, for the Doa recitation. May Allah's blessing be showered to us throughout this program. Yang dihormati Profesor Dr. Zahril Adha bin Zakaria, Deputy Vice Chancellor of Research and Innovation, University Technical Malaysia Melaka. Yang berusaha Associate Professor E.S. Dr. Mustafa bin Muhammad Tahir, Assistant Vice Chancellor, Strategic and Global Sustainability, University Technical Malaysia Melaka. Yang berusaha Associate Professor Dr. Nadlin binti Razali, Dean of Faculty of Mechanical Technology and Engineering, University Technical Malaysia Melaka. Yang berusaha Associate Professor Technologist Dr. Muhammad Rizwan bin Mansur, Chairman of the ICIM 2025. Yang berusaha Professor Insinyur Dr. Ubaidillah, the Honorable Representative from Universitas 11 Maret, UNS Indonesia. Yang berusaha Dr. Jack Fabian Rusdi, the Honorable Representative from Universitas Teknologi Bandung, UTP, Indonesia. Senior officers of University Technical Malaysia Melaka, the Organizing Committee, keynote and distinguished speakers, ladies and gentlemen. Salam sejahtera dan salam UTM kusayang menjajar universiti melonjak ke hadapan. Welcome to the 11th International Conference and Exhibition on Sustainable Energy and Advanced Materials, ICIM 2025. Before we move on to the next agenda, allow us to grab your attention to enjoy the UTM's corporate video prepared for all of us today.
University Technical Malaysia Melaka, are widely known as UTM, was established on December the 1st, 2000. It is the first technical public university and the 14th public university overall in Malaysia. UTM is situated in the heart of Melaka and is acknowledged by UNESCO as a World Heritage Site that attracts tourists from all over the world to Malaysia. UTM consists of two campuses, which are the main campus with 766 hectares that is located in Durian Tunggal, Alor Gajah, and Technology Campus in Ayer Keral, Melaka. UTM spearheads technical education and vocational training, which is known as TVET in Malaysia, that aspires to produce professional, highly skilled, work-ready graduates to the nation. The UTM education system is practical-oriented and focuses on problem-solving, teaching, executing, and experiencing learning. University Technical Malaysia Melaka offers programs that complement the local and international industry demand. As a university that focuses on engineering, information technology, and technology management, UTM Research Excellence is achieved based on UTM Thrust Area of advanced manufacturing and computing technology. With the strategic formation of the Industry University Center as a teaching factory, students may benefit from acquiring experience and hands-on training based on the latest cutting-edge technology from the industry. The strategic partnership with fellow industry players in the implementation of teaching and learning on the campus was deemed as an effective way to progress TVET institution as the main driving force of the development of the nation's economy. Through education, research, and highly skilled technical leaders for the industry.
Honorable guests, ladies and gentlemen, today we are blessed to be able to gather in conjunction with the 11th International Conference and Exhibition on Sustainable Energy and Advanced Material, a conference organized by University Technical Malaysia Melaka in association with the Universitas 11 Maret Surakarta UNS and Universitas Teknologi Bandung UTB Indonesia. This interesting fact about our conference this year is that we are able to representing to you via hybrid platform where some participants will be presenting physically while we also provide the platform for virtual presentation. With the central theme, Energy Efficient and Advanced Material for Sustainable Development, ISEAD 2025 aims to foster a broad range of sustainable collaboration among leading researchers, experts, educators, practitioners, and developers seeking knowledge sharing in addressing various issues to advance the state-of-the-art of these evergreen engineering fields. Now, we are pleased to invite Yang Berusaha, Associate Professor, Technologies, Dr. Muhammad Rizwan bin Mansur, the Chairman of the Conference Organizing Committee, to deliver his speech. We are very pleased to welcome Associate Professor, Technologies, Dr. Muhammad Rizwan.
Thank you very much, Madam Chairperson, Dr. Anita. Yang dihormati Profesor Dr. Idawati, Profesor Dr. Zaril Adaha bin Zakaria, Deputy Vice Chancellor, Strategic University Technical Malaysia Melaka. Yang Berusaha Associate Professor, Teknologis Dr. Mustafa Muhammad Tahir, Assistant Vice Chancellor, Strategic and Global Sustainability, University Technical Malaysia Melaka. Yang Berusaha Associate Professor Dr. Nadli binti Razali, Dean, Faculty of Mechanical Technology and Engineering, University Technical Malaysia Melaka. Yang Berusaha Profesor Engineer Dr. Ubaidillah, the Honorable Representative from Universitas 11 Maret, Indonesia. Yang Berusaha Dr. Jack Fabian Rusdi, the Honorable Representative from Universitas Teknologi Bandung, Indonesia. Senior officers of University Technical Malaysia Melaka, the organizing committee, our distinguished keynotes and invited speakers, fellow researchers, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Salam sejahtera Salam UTM ku sayang, menjajah universiti, melonjak ke hadapan. On behalf of the organizing committee, I'm honored and delighted to welcome all of you to the 11th International Conference and Exhibition on Sustainable Energy and Advanced Materials, in short ICEM 2025, held here in Melaka. This gathering reflects our shared commitment to advancing research in sustainable energy and materials, and I am truly grateful for your presence today. This year's edition is even more special as it is organized in conjunction with the Festival of Ideas, a celebration that highlights our collaborative efforts to showcase research, innovation, and technological advancement. This joint spirit truly reflects our shared commitment to advance sustainable solutions to the future. Since its inception in 2009, ICEM has become a respected international platform, and over the years, it has been jointly organized by UTM, together with our long partners, Universitas 11 Maret, UNS Indonesia, and more recently, with the participation of Universitas Teknologi Bandung, UTB Indonesia. This long-standing partnership demonstrates our collective dedication for fostering regional and international collaboration. Ladies and gentlemen, this year, ICEM received a total of 106 manuscript submissions, out of which 86 manuscripts has been accepted for presentation. We are highly proud to note the strong international participation in this conference, whereby we have received 47 papers, or 55% from Malaysia, and 37 papers, or 43% from Indonesia, and further contributions from Germany, Austria, which each with one paper. In terms of institutional participation, 33 papers, or 39%, came from the UTM researchers, while the remaining 52 papers, or 61%, are contributed by non-UTM participants. This balance highlights ICEM's role as a truly international and inclusive platform. The theme of ICEM 2025, Energy Efficient and Advanced Materials for Sustainable Development, is especially relevant to the world faces pressing challenges in energy, climate, and sustainability. Therefore, the conference has created 8 special conference tracks to address the issues, namely sustainable and renewable material, sustainable and renewable energy, energy efficiency and energy management, track on advanced and sustainable materials and manufacturing processes, a dedicated track on green and intelligent mechanical system design, eco-friendly vehicle science and future mobility technologies, track on surface engineering, tribology and smart coating, computational modeling, simulation and AI in engineering, thermal fluid engineering and energy optimization, and lastly, a track dedicated to vibration control, robotics and smart system, whereby within these 8 tracks, participants will present their cutting-edge research that contributes towards the building a more sustainable future. I am confident that this conference will be more than just a series of presentations. It will be a platform for knowledge sharing, networking, and collaboration, bridging academia and industry, and strengthening ties across institutions and nations. Before I conclude, I wish to record my deepest appreciation to the Faculty of Mechanical Technology and Engineering, our co-organizers, Universitas 11 Maret Indonesia, Universitas Teknologi Bandung Indonesia, the dedicated organizing committee members, our list of distinguished speakers, and fellow participants for your invaluable contribution in making ICEM 2025 a reality. I sincerely hope that all of you will benefit from this conference, gain new insights, and forge collaborations that extend beyond this event. May ISEAM 2025 inspire us to continue driving innovation in energy and advanced materials for the betterment of our societies and future generations. With that, I thank you. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera.
Thank you to Associate Professor, Technologist Dr. Muhammad Rizwan for delivering the welcoming speech. Now, it's time that we have been waiting for, the opening speech by Deputy Vice Chancellor, Research and Innovation, representing the Vice Chancellor of University Technical Malaysia Melaka, Yang dihormati Professor Dr. Zahuril Adha bin Zakaria. So, without further delay, please welcome to the stage Professor Dr. Zahuril Adha.
Thank you, Madam Anita, for the introduction. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Dan salam sejahtera. Salam Malaysia Madani. Salam Melaka Maju Jaya. Rakyat bahagia menggamit dunia. Bijak laksana kuat. Berani laksana jebat. Salam UTM ku sayang. Menjajah mesti melonjak ke hadapan. Honorable Associate Professor Dr. Mustafa, Assistant Vice Chancellor for Strategic and Global Sustainability, Universiti Technical Malaysia Melaka, Associate Professor Dr. Nadlin, Dean of Faculty of Mechanical Technology and Engineering, Associate Professor Dr. Muhammad Rizwan bin Mansur, the Chairman of ISEAM 2025, Professor Insinyur Dr. Ubaidillah, the Honorable Representative for Universitas 11 Maret, UNS, and also Dr. Jack, Universitas Teknologi Bandung, UTB from Indonesia, Tabatang for Bapak ke Melaka, ke UTM, nanti insyaAllah. Senior officers of UTM, the organizing committee, respected keynote and distinguished speakers, our fellow researchers, participants, ladies and gentlemen. It is both a great pleasure and honor for me to welcome all of you to the 11th International Conference and Exhibitions on Sustainable Energy and Advanced Network, or ISEAM 2025, which is organized by the Faculty of Mechanical Technology and Engineering, Universiti Technical Malaysia Melaka, in collaboration with Universitas 11 Maret, and also Universitas Teknologi Bandung, Indonesia, where this year ISEAM is held in conjunction with the Festival of Ideas, or FOI, in Melaka, a platform that celebrates innovation and creativity across disciplines, and making this conference even more impactful, insyaAllah. So, since its inception in 2009, ISEAM has gone into a respected platform for knowledge exchange and collaboration, and over the years, this conference has been jointly organized 9 times, as mentioned by Dr. Rizal just now, between UTM and also UNS, which is 11 Maret. And today, we are proud to host its 11th edition here in Melaka on the 35th of September 2025. Continuing a legacy of strong regional and international partnership. Ladies and gentlemen, the theme of this year's conference, Energy Efficient and Advanced Materials for Sustainable Development, is both timely and relevant as we move forward into an era defined by sustainability and global challenges. The search for energy efficient technologies and innovative materials is essential to building a better future. Therefore, ICIM 2025 bring together scientists, scholars, researchers, engineers, and students to present new ideas and share breakthrough and good network that extend beyond borders. As mentioned by also the chairman of the ICIM 2025, this year the conference encompasses 8 major tracks. There are 1 to 8. I don't want to mention all 8 tracks, as been mentioned by Dr. Iqbal just now. I believe this research will reflect the diversity of expertise presented here today, and I believe they will foster stimulating discussion and valuable collaborations. Equally important, this conference highlights the role of industry and academia collaboration, where ICIM serves as a bridge where industry can gain insight into the latest research while universities explore consultancy opportunities and potential joint ventures. Such innovations are vital for ensuring that our research does not remain confined into publication, but also create impact in society, technology, and industry. At UTM, we take pride in cultivating a strong culture of research, innovations, and publications. Conferences such as this ICIM 2025 align with our vision of becoming a world-class technical university and support our mission of contributing to the United Nations Sustainable Development Goal or SDG. And through continuous partnership with university and industry, we aim to strengthen network that benefits not just our region, but the global research community. Ladies and gentlemen, on behalf of University Technical Malaysia Melaka, I would like to extend my heartfelt gratitude to the Faculty of Mechanical Technology and Engineering, FTKM, Universitas Sebelas Mamat, UNS, Universitas Teknologi Bandung, UTB, the organizing committee, keynote and invited speakers, and our sponsors, and all the participants. Your effort and contribution have made ICIM 2035 possible, and I'm confident that the outcome of this conference will inspire continued excellence in research and innovation. So enjoy the conference. So with that, Bismillahirrahmanirrahim, in the name of Allah, the most beneficent and merciful, I'm honored to officially declare open the 11th International Conference and Exhibition on Sustainability, Sustainable Energy and Environmental, ICIM 2035. Thank you. Wassalamualaikum warahmatullahi wabarakatuh.
On behalf of ICIM 2025 Organizing Committee, we would like to convey our highest appreciation to Professor Dr. Zahril Adha bin Zakaria for delivering the opening speech. Ladies and gentlemen, as a token of appreciation, we have prepared some souvenirs for our keynote speakers. For that, we hope Professor Dr. Zahril Adha can remain on the stage to give away the token. We would now like to invite Associate Professor Dr. Nadlin Binti Razali, Dean of the Faculty of Mechanical Technology and Engineering, to accompany Professor Dr. Zahril Adha on stage. Firstly, I would like to invite the representative for our first keynote speaker, Yang Perusaha Professor Insigne Dr. Ubaidillah, the Honorable Representative from Universitas 11 Maret UNS, since Associate Professor Dr. Aditya Prabowo cannot make it physically to our event today. Next, I would like to call upon the second keynote speaker, Associate Professor Technologies, Dr. T. Boon Tuan from University Technical Malaysia Malacca to get onto the stage. Please welcome. Thank you to both of our two keynote speakers. Last but not least, please welcome Associate Professor Dr. Nadlin Betty Razali to present a special memento to our Deputy Vice Chancellor, Professor Dr. Zahril Adha bin Zakaria. Alright, thank you Professor Dr. Zahril Adha for coming all the way to our event today. Honorable guests, ladies and gentlemen, it's not going to be complete when you are in Malacca without a pantun. Merdu bertingkah alunan suara, tanpa sedar tersilap kata, andai terlanjur patah bicara, serendah hati kemaafan dipinta. With that, we have come to the end of the opening ceremony of ISIM 2025. We hope that you had a wonderful time and will continue to enjoy a fruitful day throughout the session. We sincerely thank everyone who joined us today, and our appreciation also goes to all the participants joining us online from across the globe. To commemorate this auspicious occasion, we kindly request everyone to remain seated as we proceed with a photography session. Thank you all for your kind cooperation, and we hope everyone will keep on supporting all the session ahead today. Tea breaks will be served at the foyer area before we all proceed to the parallel session at the designated room. Thank you everyone and happy conferencing.